Let's take a look at an application of the law of cosines applied to a baseball diamond. And they give us a good description of the diamond. It says, suppose a certain baseball diamond is a square 91 feet on a side. The pitching rubber is located 61.5 feet from home plate on a line joining home plate and second base, the opposite point. How far is it from the pitching rubber to first base? And so I've got a picture here that pretty much describes what's going on. We can add some of the details. We know that each of the sides of the baseball diamond is 91 feet in length. And they tell us the distance from home plate to the pitching rubber, which is located here, not necessarily in the center of the field, but it is on a line going from home plate to second base. Okay. And they tell us that the distance from home plate to the pitching mound is 61.5 feet. Okay. And then we need to find the distance from the pitching mound to first base. Okay. Um, so we've got the length of two sides, and we want to find the length of the third side. So I need the measure of at least one angle. I don't know that this is a right angle. I can't assume that. And you can kind of see the way that I've drawn it. It looks like it's not quite a right angle. If my drawing is accurate. So how can we what angle can we find out? Well, remember they told us here that the diamond is a square, which means that this corner is 90 degrees. And because we're going from one corner of the square to the opposite corner of the square on this line, basically I'm splitting this angle, right? So the measure of this angle, just this part, is going to be 45 degrees. So that gives me the angle that I need so that I can use the law of cosines. So we get if I'm trying to solve for this side, I can say that x squared is equal to 61.5 squared plus 91 squared minus 2 times 61.5 times 91 times cosine of 45 degrees. Okay. And you can continue to solve actually for x, but that should lead you to the length or the distance from the pitching mound to first base.